Welcome to a lecture on the security of operating systems. The first module in this series will focus on operating system security models illustrated by Windows systems. We will try and answer the following question. What level of protection can be offered by an operating system? Let's start with basic security. What sort of protection can be expected from operating systems? An operating system must above all guarantee the availability of provided services. We as users need to be sure that the tasks we want to execute will be executed. We also need to be sure that the system performance will be reliable, for example, that the system will not fail. And the aspect that is most relevant in this course is that the data stored and processed by an operating system will remain secure and confidential, and that its integrity won't be compromised. Modern operating systems, or any of the computers we used, are almost always connected to some network. They're also almost always connected to the global network, the Internet. Their environment supports a number of applications which exchange data with external services without our knowledge. This is a problem because we have no control, or little control, over the data that can be found in our computer and is processed by it. A good example of this are antiviruses, or any other programs that update regularly. Some developers set the default control to such an aggressive level that an antivirus checks for virus database updates multiple times per minute. If you monitor network traffic, you'll see that your scanner sends out an update query regularly, even every 15 or 20 seconds. To standardize the security that is provided by a computer system, a classification for evaluating security levels has been introduced. Initially, the assessment criteria of operating system security were published in a document called the Orange Book. It was part of a Rainbow book series on computer system security. Several years later, the evaluation standard was updated and systematized. Today, the binding standards are the Common Criteria for Information Technology, the CC norm. As you can see, there are several standard categories. The table above shows relationships, or the corresponding security levels under the Orange Book and the Common Criteria standards. Let's start with the most basic systems. This is the D division, or the first EAL level. To be classified at this level, an operating system doesn't have to offer any guarantee of protection. The system doesn't support, for example, the separation of user sessions. This means that the physical address to the computer means de facto gaining full control over the system. This includes the ability to open and modify other users' data. To give you an example, the Windows 9X series systems are classified at this level. The second level provides for discretionary data protection. A system is required to authenticate and authorize users in a secure manner. Once identification is completed, prior to executing each command, a user will be verified for having appropriate privileges to run it. Early Linux and Unix systems are classified at this level. The third level systems enforce access control. Adding to the features supported in Level 2 systems, systems classified at this level are required to provide for user activity monitoring. Each allowed or disallowed operation has to be logged. An example of a system classed at this division is Windows NT. The fourth level is restricted to systems that support labeled security protection. It's an implementation of a model known in cryptography, the security theory, as the Bell-LaPadula model. We'll come back to this in the future. In a nutshell, the model assigns sensitivity levels for certain types of data. A person with a given level of privileges will be able to access only the data that was assigned to the corresponding or lower sensitivity label. Newer Windows and Linux systems are classed at this level. The fifth level also enforces structured protection. It requires the operating system structure to allow for the monitoring and control of all operations executed by the system. This means that the uncontrollable tampering with data of another process is impossible. All launched operations are atomic operations, and the access to the data processed by it must be authorized. The fifth level doesn't encompass popular operating systems. They don't even aspire to it. Some specialized versions of systems implemented on specific machines may be classed at this level. The sixth level systems require the provision of process isolation. Each security-critical operation must be separate and independent in the system. The highest level, the seventh level, is assigned to those systems that are able to formally, for example mathematically, verify their security. The systems have to effectively exclude any possibility of successful attacks. The security of these systems can't depend on configuration or user behavior. It has to offer formal assurance of full protection. Level 7 encompasses several devices, not systems. They're definitely not commercially available. The modules that deal with operating system security will talk above all about system security boundaries. The concept of a security boundary is vitally important as safeguarding a system against cyber threats amounts to risk management. We've realized this early on during the first modules of the first part of our course. To manage the risks in a conscious manner, you have to be aware of the protection that is offered by your computer system. You also need to take note of the fact that an operating system can only protect data when it's running. It doesn't protect data against local attacks. We'll try to give you hints on using popular operating systems in a considerably security-conscious way. And finally, we'll also take a look at the concept of granting rights not to users, but to the programs launched by users. This different security model has been supported for many years in many computer systems, also in Windows systems. This security model we've just mentioned, a model that is based on code on access rights, is on the shelf but seldom used. This means that it's the task of the administrator to stop users from launching any potentially harmful programs. In the next lecture of this series, we'll learn about the implementation of this. We'll also take a look at the techniques and tools for independent detection and removal of malware. The malware we referred to are mostly rootkits, programs that attempt to hide from users and administrators. At the end, we'll evaluate the security of our systems. Configuration errors are in practice the largest source of problems with protection measures' effectiveness. Users and administrators often don't modify the default configuration, believing it's set to provide the highest security, which is not true. Or sometimes reconfigure their systems in a way that lowers the security even further. See you in the training.